hoping we would get to this, but of course I always jam too much into our sessions together. So we're looking here at Odyssey. If you don't have it open now, please do so. This right here is the builder function that I mentioned in item 4 of our hydrogen peroxide and chicken liver lab. When I open up that builder, I have the option to choose different elements from the periodic table in this entry-level mode. And that's exactly what we're going to do here. We are going to create hydrogen peroxide. I'm going to need 2 oxygen atoms. I'm going to need 2 hydrogen atoms. Now, these colors are actually very important. Turns out that chemists use all the time. Red for oxygen, white for hydrogen. Now, this is the minimize tool. That now gives us the best picture of hydrogen peroxide that scientists know. We're going to, in a separate window, create another molecule. Notice how I've just created a new builder. And this time, it is water that I'm asking you to build. And then finally, we're going to make oxygen. In each case, I want to minimize, make sure that my models reflect the reality that chemists understand at this point. So here's my hydrogen peroxide, here is my water, and here is oxygen. So if I've completed, hydrogen gas is the next thing. And somehow my builder is out of sequence. I'm not sure what happened there. But, whoa, I clicked with carbon being shown. I can always get rid of that. That little X will eliminate things. But we're going to make hydrogen. And we're going to minimize hydrogen. And then we're going to move this. Using the command key on my keyboard, I'm able to do that. Now that little red arrow is just to indicate that we could rotate around that bond, but we're not going to. And we do want to measure its length. So to do that again, let's see, I'm kind of out of order, but hydrogen peroxide, water, an oxygen molecule, a hydrogen molecule. Now, bond lengths in hydrogen peroxide. So I go back to hydrogen peroxide. This little table right here is where I'm going to be able to add different properties measured directly on my molecule. So the hydrogen to oxygen bond length is 97.6 picometers. That would be 10 to the minus 12 of a meter. The oxygen-oxygen bond is 145.3 times 10 to the minus 12 meters. And then, just to double check, 97.6 picometers again. Now, what's interesting to me is that you can, I think we can do this, continue to add on these distances and display all of them at once. So let's try that. There's my first distance, and in very faintly you can read 97.6 picometers for the distance between oxygen and hydrogen at that end of my molecule. Here, I'm going to select these two to get that 145. What I've done there is to use a stretching motion on my trackpad to enlarge my representation there. And let's see, those two, oh, there we go. That gives me the ability to see all 3 of these bond lengths at the same time. Okay. There we go. I'm going to leave it that way. Whoops. If I do that, it's going to give me that distance. So let me delete that one. Try one more time. And there we go. Okay. Now, Odyssey has a lovely feature being able to make images of things. And what I'm doing here, unfortunately you can't see it, but there's the word snapshot. And I can save these images as, in this case, hydrogen peroxide. It's going to be right on my desktop. PNG files are a little more flexible. Okay. Water, same idea. I'm using the command key to center it in the middle of the picture that you're looking at. And then I've just used a stretching motion with my fingers on my trackpad. And I now have water. I'm going to create a similar table to what you saw me do before. And I'm going to label the bond distances in my water molecule. There we go. And then do the same, oops, right here. So both of my hydrogen to oxygen bonds are identical at 96.9 picometers. Okay, that's just what we did before. There we go. Okay, so have you write those down. Create a snapshot, and now water. Oxygen only has one bond. That makes life a little simpler for us here. Again, a sweeping motion on my trackpad. And now I've got my bond length there. A little snapshot. Oxygen. Hydrogen. Sweeping motion with my fingers on my trackpad. Bond length, there's only one. And a very short distance between those two atoms. Okay, we've got all the bond lengths in hydrogen peroxide, water, oxygen, now hydrogen. Oh shucks, and I did not create the Google Sheet assigned to you, but I'm going to do that as a separate step in Schoology. So look for that so that you'll be able to copy these things down. But this is how we build molecules in Odyssey, and this is what we're going to be exploring. Now, the one thing that's of importance here is that oxygen has a bond length of 121.6 between those two oxygens. But in hydrogen peroxide, the distance is much longer, 145.3 picometers. A longer bond in hydrogen peroxide, a shorter bond in oxygen. We proved that it was oxygen that we formed when hydrogen peroxide is exposed to chicken livers. So we're going to talk quite a bit about this chemical reaction. All right, there you go.